Okay, recording in progress. Somebody with a nice voice that can read example 1 for us. Nobody's looking at me. Everybody's avoiding the eye contact. Mohini, thank you. Yeah, just to read the question. You'll do it? Okay, thank you, Daniel.
Laura works part-time at a flower shop. She's making a flower arrangement for a customer with a total of 10 flowers, using 2 types of flowers. She is asked to use 4 times as many carnations as roses. How many of each will be in the arrangement? Use graphing to solve the question.
Perfect, thank you. So before anything, since this is a word problem, I need to define my variables. So what should we let? So,
for the tickets to dance.
But for period 4, I don't have period 4.
You have them on this period, don't you?
Is that in the announcement period 4?
Oh, you're right. You don't have a 4?
I don't have a 4. Dean is in here, period 4.
Dean Foot?
Yeah, but it says my name on it. So in the announcement, it says period 4 teachers please.
And you have a prep period 4.
Yeah.
Thank you. I'll figure that out. Thanks.
Okay. Okay, so what are my 2 variables here?
X and Y.
Okay, X and Y. Okay, so what should we let X represent? Number of roses. Good. Number of roses. And what should we let Y represent then? Number of? What type? You have 2 types of flowers. Carnations. Good. Do you guys know what carnations are? Yeah, for Mother's Day flowers. Mini roses, basically. The cheaper rose. Yeah.
Can't you just write the number of carnations as 4x because it's 4 times roses?
Oh, we're gonna build our equation.
Oh, you have to build it.
Yeah. Okay, so first equation. Remember, our first equation is always the number of. So in total, we want 10 roses. So what do you think my first equation is going to be?
X plus Y equals 10.
Perfect, that's it. X plus Y equals 10. See, it doesn't have to be hard. You got first equation, you have at least 1 point in this question, just for writing that. Second equation, 4 times as many carnations as roses. So this is the tricky part. Sometimes you have to read it a few times. Which do I have more? Do I have more roses or do I have more carnations? Nikki? Carnations. So I'm going to write, I'm going to write Y equal then. Because carnation is Y, right? So I'm going to write Y equal. So 4 times as many means my equation is going to be Y equals 4x. Okay. I know some people have trouble thinking, is it x equals 4y or y equals 4x? So a little trick is when you think about which one is more, the more one is usually the one that you write first. Okay. Now that we have this, we can graph because we want to use graphing to solve this question. Graphing. Okay. So y equals 4x. What's my y-intercept here? Y equals 4x. Y-intercept is 0. Alright, so I have my y-intercept at 0. My slope is 4x, so my slope is 4. Up 4 over 1. Up 4 over 1. Alright, there's my line. Eek. Alright, there's my equation number 2. Right here. So far, so good? Alright. Now this one, I have to rearrange it into y equals mx plus b form. So if I rearrange this is y equals negative x plus 10. Okay, right? Because I moved this over, so it's negative x plus 10. So what is my y-intercept here? Oh, Fatima? Yep, here. What's my y-intercept here for the red line? Y-intercept? Not everybody at once. Amma?
10.
10. And my slope. What's my slope?
Negative
N-
Negative 1.
Negative 1. Good. So down 1 over 1. Down 1 over 1. Down 1 over 1. Down 1 over 1. And there we go. This is my equation 1. Okay, so now we can clearly see what is our POI. What's my POI? Corin? What's my point of intersection? Oh, this. 2, 8. Okay. But what does the 2 represent? What does that 8 represent? Is it 2 rows or 2 carnations? Two. Man, it is a Friday. You guys are so quiet today. 2 what? How many? Roses, right? And that's why it's so important to define your variable at the beginning. That's how you know which is which. So 2 rows, 8 carnations to make that bouquet. Okay. Okay, any question on this example? So you're guaranteed to see a question like this on Tuesday. A word problem where you have to come up with the 2 equations, graph it, and find the intersection point. Okay, so if you have trouble with writing it into y equals mx plus b form, let me know. I can come over during class today to help you set up the equations. Okay, number 2. 2 cartons of milk contain different percent of butter fat. How much 1% milk is needed to mix with 5% milk to give 10 liters of 4% milk? Okay. What? Okay, so let's highlight the important numbers. 1% milk, 5% milk to make 10 liters of 4% milk. Okay, so our 2 variables, let x be. What are my 2 types of milk here? Yeah. Sorry, 1% and right. So 1% milk and 5% milk. Those are my 2 types of milk. Okay, so always define your variables. That's the first step. Now we can make our equations. First equation is always the amount, the number of. So x plus y equals how much? How much are we making? Rosie? How much? So the 10 liters. Good. So x plus y equals 10. Second equation now. This is the tricky part. Okay. Whenever we write an equation, we always have to change the percentage to a decimal. So what is 1% as a decimal? Rosie?
0.0.
Yep. So I want 1% of this milk plus 5% of the second type of milk equal. Okay, I want to see who knows what it equals to. What should I write it equal to? Jay?
0.04.
Okay. Anybody want to add something to this?
0.04 times 10.
Good job. Why do we have to times 10?
Because it's 10 liters.
Yeah. So if you remember, equations have to be equal. The percentage times the amount, percentage times the amount, percentage times the amount. So this was a very tricky part. So remember that.
Why would you automatically assume that you can just put 10 though? Or are you assuming that the kinds of 1% and 5% milk are already like a liter? Sorry, I'm overthinking it.
You are overthinking it. This is that's what you're trying to solve for. You're trying to solve for how much of that milk you need. So it's not 1 liter. We'll find out how many liters we actually need.
But do you assume that it starts off as initially a liter?
No.
Okay.
Yeah, so if I write it in full, this would be like the number of liters of 1% milk, number of liters of 5% milk. That's what we're trying to look for. Okay, so this part, be very careful. Remember that. Okay, but as we know, we don't like to deal with decimals. Okay, how do I get rid of decimal? Think back to last week when we did the review test. How do we get rid of decimals? We times the whole equation by, I can't hear, more. 100, yeah. If I multiply this whole equation by 100, I can get rid of all this decimal. We just don't like decimals. No offense, but it makes the math look hard. So 0.01 times 100, you get x. 0.05 times 100, you get 5. And then this, be careful, 0.04 times 10 times 100, you get 40. Alright, so this is 0.4, and then times another 100, you get 40. Do my equations look a lot nicer right now? Oh yeah, okay, so let's say solve by substitution. I'm going to add solve by substitution so that we have the three types, or 3 types. Okay. So substitution means I have to isolate one of the variables. So out of these, doesn't matter which one you do. So let's say I isolate this x right here. So my equation becomes negative 5y plus 40. Right? What am I going to do with this equation now? It was in the homework. I have to sub it into, Rosie? Yeah, the first equation to solve for y. So sub x equals negative 5y plus 40 into equation 1. So negative 5y plus 40 plus y equals 10. Right, this equation, I replace the x with this. Right, so now to solve this, negative 5y plus y is negative 4y. 10 minus 40, because it's on that side, is minus 30. Divided by negative 4, so you get 7.5. What's my unit? Liters. Right, so Caitlin is not 1 liter. They actually need 7.5 liters.
But the numbers start off as 1 liter, right? Not milliliters or anything. I'm overthinking. I'm just gonna stop.
Okay, now that we have this, we can sub it into equation 1. Sub this into equation 1. So we know that x plus y is 10 equals 10. So that means x equals 2.5 liters. All right. So my point of intersection is 2.5, 7.5, But again, I need to know 2.5 what and 7.5 what. So, therefore, yeah.
Oh, sorry, I had a question.
Okay, sure.
Can you repeat how you got to the answer negative 5y plus 40 plus y equals 10?
Oh.
Specifically the 10 part, I kind of missed that.
Because we substituted into the equation.
Oh, okay, great.
Yeah, that's where the 10 came from. It was from the original question. Yes.
Sorry, are we going to be allowed to use decimals during the test?
Good question. Yeah, I think with this unit, yeah. Last unit I didn't allow decimals because I was testing you guys on fractions. So now, yeah, you can use decimal. You can use 7.5 liters, 2.5 liters.
Okay. And on the test, is it going to specify to do by substitution or elimination?
Yeah. One question each. Okay, so therefore, Caitlin will need to use 2.5 liters of 1% milk and 7.5 liters of 5% milk to make her the 4% milk. You know, she could have just went to the supermarket and buy 4% milk instead of mixing it on her own. But why do you even want 4% milk?
I don't even mix the milk for the percentages. Well, what is the origin behind it anyway? When we have a supermarket 5 minutes away from the home.
Exactly. So we could just buy this, but hey, but you know, the things that are pre-mixed are usually more expensive. All right, last question right here. Okay, so this last one, somebody with a nice voice that could read me example 3 and just reading it. Daniel, since you shown as that you have a very nice voice.
I can do it. Ian can use 20 kilometers downstream in 5 hours, I'm assuming.
Hours, yes.
On the return trip, it takes him 8 hours to travel 16 kilometers. How in the world? Anyways, determine his average canoeing speed and the speed of the current. Now, can I just say, Ian, I respect you very much, but how did you reach the end of the stream faster than it took to go back home?
Okay, so yeah, why is his return trip taking so much longer? Uphill or against the current, right? So as you guys know, if you paddle,
The paddle harder.
well, Ian is a human. Okay, so when you go upstream, downstream, that's why it makes a big difference in terms of your speed and time. So with these type of questions, you want to set up a table. So going upstream, downstream, distance, okay, time, and speed. Okay. You don't need the line so long. Okay. Okay, so going upstream, how long did it? So what distance did he take to go upstream? Okay, so downstream was 20 kilometers. Upstream was how much? Here, I'll highlight the numbers as well so that it stands out. 5 hours, 8 hours, 16. Okay. So what was the distance for upstream? Rosie? 16 kilometers. It feels like I only have Rosie and Daniel in class today. Participation marks, guys. All right.
That's
For
the class. It's in the course right now.
for upstream, how long did it take? How long did it take for upstream? You're just reading off the question. Yes, 8 hours.
5 hours.
And then for the downstream, it was 5 hours. Right. Okay. The speed.
Alright, now we actually do equations.
Okay. So, oh, my bad. I forgot to let statement. Let's say let P represent paddling speed. And then I'm going to let C to represent the current speed. All right. So instead of canoeing speed, I use P for paddling because I don't want the two C's to make it confusing. So one is paddling speed and one is current speed. Okay. So when you're paddling downstream, you have your speed, but what else? Yeah. The current speed to help you or to go against you? To help you. So what happens to my speed then? Faster. So your speed is P plus C because you're going with the current. You have the current to help you, so you're going faster. So it's the paddling speed plus your current speed. So in that case, what is upstream then? Yeah, it's slowing you down. So what do you think I should write here? P minus C. Excellent. Does it make sense? Yeah. Okay. Now think about the. Have you guys seen this triangle in science? What is this triangle? What do DST stands for? Yep. Distance, speed, time. So those who haven't seen this triangle, I use it now too. If I want to find distance, the formula is speed times time. If I want to find speed, the formula is distance divided by time. If I want to find time, I do distance divided by speed. So this is a very useful triangle. I use it to this day. So let's do distance equals speed times time. Let's set up our two equations this way. Okay. So first equation for upstream.
16 kilometers time
Equal.
equals speed times h.
Good. Okay. Don't include units in your equation because otherwise it will look.
16 equals s times 8, or other way around.
Yep. Yeah, speed times is the same as time times speed. So I just rule it like this instead of P minus C times 8 because it just looks nicer. It looks like how we are used to seeing it. The format is more friendly. Okay. Second equation then. Same format. How would I set it up? Xiao?
20 equals 5 times brackets plus brackets.
Perfect. Okay. Now why I have it written like this is because you can tell you have to distribute that 8. If I wrote it in the back, people miss it. So that's why I wrote it like this, a way that we are used to seeing. Okay, so when we expand this out, we have 16 equals 8P minus 8C. Bottom equation, 20 equals 5P plus 5C. Right. Solve by elimination. Elimination. 8. And if I were to solve by elimination, you guys know how to do it because it was from your homework yesterday. I trust that you guys did your homework. Alright. I want to get rid of either the P's or the C's. Which one do you just want to get rid of? Yeah? C? Sure. Okay, because Caitlin said so. Okay, so I want to get rid of the c, so that means I have to multiply this whole equation by 5. Because I need the coefficient. My lowest common multiple between 8 and 5 is 40. And I would have to multiply this whole equation by 8 then. Okay, so let's see what happens. 16 times 5, whoops, 16 times 5 is 80.
Excuse me, may I ask a question?
Not yet. Let me finish the problem. 8 times 5, 40. And 8 times 5, C, 40C. Okay, bottom, 8 times 20, 160. 8 times 5, 40. And then 8 times 5, also 40. Oh, actually, we have 2 choices. But we'll be consistent. Caitlin said get rid of the C, so we'll do that. Now I can add or subtract my 2 equations to get rid of it. So if I want to get rid of the C's, should I add or subtract my equations? Add. I want to get rid of the C's. So negative 40 plus 40, that's how I get rid of it, right? If I subtract it, I don't. So 80 plus 160, I get 240. 40p plus 40p. What's 80? 80p, good. And then negative 40c plus positive 40c, that's gone. And so therefore, when I divide, what is p? 3 what? What's my unit? What does P represent again? Paddling speed. Speed. So what unit? Yep. That's not a speed. Per hour. All right. Oh, here, I'll move that up. Okay, and how do I know it's kilometer per hour instead of minutes, meters per minute? You take a look at what you're given. So this is in kilometer, this is in hours. That means the speed is in kilometers per hour. Ian is a very slow pedaler. Okay, and last thing we have to figure out what C is. So I'm going to sub this into any equation. Any of the equations. So let's say I sub it into here. So sub P equals 3 into the first equation, which is this. Okay, so 16 equals 8 times 3 minus 8c. So when you move this over, 4, whoops. Okay, so when you move that over, you get negative 8 equals negative 8c. So what is c? 1 what? Kilometers per hour. If I get a negative numbers, does it make sense? No, because speed, you cannot go negative speed. Okay, so therefore, Ian was pedaling at 3 kilometers per hour, and the current was 1 kilometer per hour. Okay, so I know these ones are a little tricky. I try to go over ones that are like the hardest one from the textbook, so then if I teach you guys the hardest ones, then you would know how to do the easiest ones. Make sense? Yeah. Okay.
So
But it's still, but it will still take practice. Once you do a couple of these, then you'll know that it becomes easy. Okay. So I need you guys to practice it. I want you guys to do at least the bare minimum, number 1, 3, 7, 8, 9, and 13. So that's only 6 questions, 6 word problems. If you take a look at the Brightspace, I actually included 20 word problems there. So you could feel free to do more, but bare minimum, do those 6. So it's linear system word problems. If you go scroll down right here, you'll see 20 word problems. Alright. And I guess a little hint is the 3 problems is gonna be from these 20. Like it will be like maybe change the numbers a little, but it's gonna be from these 20 questions. Okay, and the last page, answers. So check your answers to see if you're doing it correctly. Any questions? So word problems does take practice, so make sure you try it. All right, and I will upload this video on Brightspace because I know this is one of the harder lessons where you have to, like, you might have to watch it again. So I will upload this on Brightspace right now. Okay, so let's get working. Questions are on Brightspace.